Good morning, class. So, in the lecture number 8, we are going to discuss about the Nernst equation for single electrode. And as we had already discussed different types of electrode like metal ion, calomel electrode, hydrogen electrode, and redox electrode. And in our previous lecture, we had discussed about the Nernst equation, the common Nernst equation, in order to find out the EMF. So here we will deal with the Nernst equation for different electrode. What is the Nernst equation? What is the formula for the Nernst equation when we are dealing with the different electrodes? So the very first is the metal ion electrode. And if you take the first example in case of a zinc and zinc ion, so this is the equation. And in terms of Nernst equation, what would be the equation? It's like this. Here A is the notation for activity, as we had discussed in the lecture of activity and activity coefficient. So this is how the Nernst equation will be written. Okay. Now, if we put the values of along with the change from natural logarithm to log, the equation will be changed. Okay, we had already discussed. And for the solid case, we all know that for the solid, the activity will be 1 only. That means the unity. So a zn can be written as 1, and if you put all the values here at so the equation will look like at zn plus 2 zn e naught zn plus 2 zn, and this will be 0 0.059, and n in this case n will be what, 2. Okay, n will be 2 because we have 2 electron, and log 1 upon a zn plus 2. So you can update also this. So e zn plus 2 zn e naught zn plus 2 zn, and if you change the sign here, it will, if it is plus 0 0.059 upon 2 log a zn plus 2. So if this will comes, then the sign will be changed. So this is what the simple equation in case of metal ion. Let's take one more example, that is example number 2. If we have ag plus and e negative, so this will be ag. So here the value of electron, then means the n is what, 1. So I'm going to write the direct equation. Okay, so what is the equation in this case? E ag plus 2 ag and e naught ag plus 2 ag, and I'm writing directly. Okay, because it is ag upon ag plus activity ag upon ag plus, so I'm writing directly. So this will be plus 0 0.059. Here we have only 1 electron, so the value of n will be what, 1. So upon 1 and log a ag plus. So this is how you can calculate the EMF of metal ion. So here the general equation, what is the general equation? So the general equation, if I'm taking m n plus then n e negative, this will give m solid. So the general equation for Ne is E m n plus 2m equals to E naught m n plus 2m, and if I write directly, so it will be 0 0.059 upon n and log m n plus. So this is the general equation in case of metal ion. Okay, now let's take the second electrode, and that is the hydrogen electrode. Hydrogen electrode, very common, the standard hydrogen electrode, the hydrogen electrode. So the equation for the hydrogen electrode is again H plus with release of with gaining one electron, this will give half H2 or hydrogen gas. So in this case n is what? 1. Let's write the Nernst equation in this case. So Nernst equation in this case is E H plus 2 H2, then E naught H plus 2 H2. Then again I'm writing the value. So here RT upon F, then Ln, and activity. Here I'm writing activity of this C A H2, and this half the coefficient will be comes into the power, and upon activity H plus. Okay. Then again the if you put all the values and activity, the standard if hydrogen gas at 1 atmospheric pressure, the pressure of hydrogen gas is 1 atmospheric, so AH2 will be equals to 1. AH2 is 1. So this is now the change of equation. E naught H plus H2. Here I'm writing the whole value 0.059 upon 1, because in this case we have one electron, so no need to write that one. Then this is the log 1 upon AH plus, and again see, this is what, this is the electrode potential value, and we know that the electrode potential value for hydrogen electrode will be 0. Okay, it is 0 always. So standard electrode potential of hydrogen electrode is 0. Standard electrode potential of hydrogen electrode is 0. So I'm writing the value here, E H plus H2, this will be 0. Okay, this will be 0. So it is, and if you put this AH plus 2, so this will look 0.059, this negative will be changed. Okay, 0.059 log H plus. So this is what the equation in case of, these equations are very important. Sometime in the competitive examination these equation asked directly, and numerical also based on these equation. So this two electrode we had discussed so far. One is the metal ion electrode. Here we taken two cases, one is of zinc and other one is of silver. So this is the common equation for any metal ion, and in case of hydrogen electrode the equation look like this. Okay, now moving ahead, we are then the third equation is calomel electrode, important one. Okay, so third is the calomel electrode. So the calomel electrode, let's write the equation first. Hg2Cl2, the paste of mercurous chloride solid with 2 electron, this will give 2Hg, is in liquid state, and 2 electron. So here we have 2 electron, got it? So now the Nernst equation. So for the Nernst equation I am writing directly here Cal. Cl indicate what? Calomel. ECl E naught Cal minus RT upon 2F, because we have 2 electron, then Ln. Okay, so what's about the activity? So activity of AHG, and this will be square because of the 2 coefficient. Similarly ACl negative, and this is again the square, and upon AHG2Cl2. This is very important to remember. Okay, because in this case we are writing only ECAL. So ECAL is the indication of what? Calomel, the cell calomel electron. Okay, now For this case, as we know that the a square hg, a square hg is nothing but this one, okay, this one is 1 for pure liquid, and similarly a hg2cl2 is also 1. This is for pure solid. So these two is unity. So what is the cell reaction again? So ECAL, E not CAL, and here I am writing the values. So 0.059 upon 2 log. This you should remember. This is unity. This is unity. So here we have only activity of chloride ions. So this is what the change. Here we cannot change it is in plus sign, or this is in minus sign. So this equation is different one from the past two equation. Point to be noted. In the previous equation you can see that as you put the sign, as you put the AH plus into above, that the sign will be minus 2 plus. So as in case of metal ion electrode also, here we have a minus sign, and again when we put this to here the sign will be changed. But in case as these two values, this value and this value is unity, so no need to change the sign, and this is what the reaction. Okay, so this is the third electrode, galvan electrode, and now the fourth one, the last actually, this is the different one. Okay, these are the single electrode. So now the Nernst equation for double electrode. Here we use double electrode. So double electrode is nothing to worry. Double electrode is nothing but the redox electrode actually. So here we are talking about the redox electrode. Okay, we had already discussed these electrodes in detail. So let's write the equation first. Here a same metal can oxidize and reduce. So Fe plus 3 I am taking with Fe plus 2, and here the value of electron, that means the N is what? 1. So let's write the Nernst equation for this. E Fe plus 3, then Fe plus 2, okay, then E naught Fe plus 3 to Fe plus 2, again RT upon the value of N is 1, so RT upon F only, and Ln, this is the activity of Fe plus 2 and the activity of Fe plus 3. Okay, here both is in ionic form. Okay, so you cannot take unity to anyone. Let's write the complete equation. So we can write Fe plus 3, Fe plus 2, E naught Fe plus 3, Fe plus 2, and if you write the plus sign here, RT upon F, Ln activity Fe plus 3 and activity Fe plus 2. If you change Fe plus 3 to Fe plus 2, E naught Fe plus 3 to Fe plus 2, if you change in the value, this will be 0.059 log A Fe plus 3 and A Fe plus 2. So this is the final equation in case of redox double electrode. Okay, any you can take. Okay, can we go for another example? In case of redox electrode, we can take one more example. If you have a double electrode like this, Zn, then copper plus 2, so this will give you Zn plus 2 and copper. Okay, so what will happen in this case? If you I'm writing the Nernst equation, so E and E I'm writing directly. Okay, E naught RT upon 2F here because N is 2, and Ln. Now let's write how we will write it. Zn plus 2 ACU upon A Zn and ACU plus 2. So the solids, this is the solid, this is the solids, the pure solid is always unity. So ACU and AZN is what? 1, as they are pure solid. So E equals to E naught and RT upon 2F ln A Zn plus 2 and A is the activity, okay, copper plus 2. If you change it, this can be written like this: E naught plus RT upon 2F ln A Cu plus 2 and A Zn plus 2. And if you put the values, equals to what? Equals to uh, E naught plus 0.059 divided by 2 log A Cu plus 2 and A Zn plus 2. So this is the equation of redox electrode. Okay, so this is how you can discuss the different Nernst equation in different cases. So in this case we had discussed the Kelvin electrode, also the redox electrode, and metal ion electrode, and the hydrogen electrode. So this is how we have to discuss. There is one more thing, that how you can calculate the equilibrium constant, that is the K. Okay, so this and other thermodynamic quantities, like G and H, that means the Gibbs free energy and H, these all we will discuss in the last lecture. That would be probably the last lecture for the electrochemistry third. So this is all about from this lecture, and I hope you are watching my videos. Especially I'm talking with the fourth semester students, BSc B.Ed fourth semester students. Please do watch my videos, and if you have any doubt, any query, any comment, please go through that and write your comments in the comment box, or you can directly send to your queries or your uh, ideas. If you have any ideas that to how we can make this class more effective, so just share your ideas to my WhatsApp number. This is my WhatsApp number I am writing. Okay, please comment the questions which I asked at the end of the video. I haven't received any answer so far, but I am hope that you will soon give me the right answer or the probable answer. Thank you so much. Thank you so much for your watching.